Hello everyone. In this tutorial, we are going to learn about how to deploy deep learning models using TensorFlow JS. So without wasting any time, let's get started. So what is model deployment and why it is important? So if you see the stages of a machine learning life cycle, it starts with the business needs, and then we'll be gathering the data, and we'll be thinking which models works best on that data, and then we'll be training those models, and then finally we'll be testing those models. So this is an iterative approach from business needs to the test models until you're satisfied with the results. So whenever you are satisfied with the results, and then the next step will be deploying the models, and then you will be connecting that to your business apps or Android or iOS or web, whatever, according to your requirements. And then you'll be monitoring, and then if you want to optimize something, you'll be optimizing them. After uh, you're monitoring that, you'll be getting some performance issues, or so if you think it should be improved, you'll be improving that one. And this is what the complete business machine learning life cycle is, and why the model deployment is very important. So if you see, let's take an example of a student or the pet projects. So all these projects will be stopped after building and testing it locally, but they don't deploy those models. So here the model deployment is very important. Let's say you're sitting for an interview, and you're saying that you did this project, and uh, this project will generate this result. But how can that interviewer believe you, whether the output is correct or not, whatever you are saying? So whenever you deploy those models, you can show them the live working of the project, so where you can give the input and where you can get the output. So then the interviewer can believe you, and he will be impressed with that one. Like he can think like, oh, you know the deployment, how to deploy the machine learning models as well, not only the developing the machine learning models. So he may be impressed and can uh, take the further steps in the interviews. So the model deployment is important here, and it also important for the businesses where they develop multiple products, and they want to and they want end users to use it. So then they'll be deploying those products, then the end users can make use of it. So this is where the model deployment is very important. And there are many tools to deploy your models, like Flask, Azure, or Kubernetes, or there are many other tools. So TensorFlow serving is one of them. So so let's first understand what is TensorFlow serving. So TensorFlow serving is a flexible and high performance serving system for machine learning models and designed for production environments. And then TensorFlow serving makes it easy to deploy new algorithms and experiments. This is what the most important thing in the deployment process, while keeping the same server architecture and APIs. It also provides out of the box integration with TensorFlow models, but can be easily extended to serve other types of models and data. So first, so the next, let's understand why TensorFlow serving. Why not the other tools? So whenever you deploy your models, you may face few challenges, like you want to change the model in production. Like you improve the performance of the model, and you want to deploy that one instead of the previous one, without affecting the server. You can do that easily with the TensorFlow serving. And if you think that, okay, the deployed new version is not working uh, perfectly for every user, and you want to roll back to the previous stable version, that also you can easily do with the TensorFlow serving. Or whether you have a use case like you want to test multiple models or serve different models to different types of clients. Mostly we can say A/B testing here. So whenever you want to do that, you can use TensorFlow serving, which works perfectly with all these three use cases. So that is the reason why we choose TensorFlow serving for this tutorial. And let's understand a bit about the TensorFlow serving architecture. So this TensorFlow serving is composed of few abstractions. These abstraction implements APIs for different tasks. And the most important ones are servable, dynamic manager, loader, and the source. So let's understand how the life cycle of a servable is. So it starts with the source. The main responsibility of that source is to uh, have a look at the models on your disk or the local file system. So it's always keep an eye whenever a new model or the new version of existing model uh, is even in the disk or in a file system. So uh, it will get that one, like it will understand, okay, there is a new model, and then it creates the loader for that one to load the model. And this loader knows everything about the model. This like let's say this can understand what is the graph of the model and where the weights are, and many other things like how what are the computation requirements for the model, the RAM size or the GPU memory, and the other things, the metadata. It also knows the metadata of the model. And this loader will be having a pointer which points to the model which is on the disk or on their file system, like local file system. So it will be pointing to that path, to that model exactly. And one thing which loader can't do is it can't load the models itself. It needs some permissions to load the models. So that those permissions will be given by the dynamic manager. So whenever the source creates the loader for a new model, it also says the manager that there is an availability of the new models. Let's say the aspired new models. And then this manager will be having a multiple use cases, like let's say when you just given some new model which don't have any other versions, it is the only version. Then what it will be doing is uh, it will directly push that model to the deployment, and then whenever the resources are available for loading that model, it gives permission to the loader to load this model and serve the users. But the other type of use case is whenever you have multiple versions, then the manager will consult the version policy plugin, which is here. So it will consult what are the next steps to be taken. So this version policy determines what would be the next step, like unloading the previous versions, or loading the next version of the model. And it also gives the required resources to the loader to load the old versions or the new versions of the model. And that is what the dynamic manager will be doing. And then finally the client will be making the request, right? The client can ask a specific version of that model. Let's say we have three versions of a single model, and the client can ask, okay, I need the second version of this model. And then this dynamic manager will do whatever the things it need to, and then it will finally handle the handler uh, to the client to do some operations like inferencing or predicting some results or whatever the client can do. He can do that one. Or by default, the dynamic manager will be giving the latest version of the available model. And after analyzing all those factors, this handler will return the uh, results. Like this dynamic manager will be giving the handler to the client. The client will be performing some operations. He may request predict the output of this input. uh, all the operations will be done at the back end, and it will give the results to the client. So this is how the TensorFlow serving architecture will be. The most important things are these four things: uh, the servable, dynamic manager, loader, and server. So this is a little bit high level overview. If you want to understand in depth of how this works, please look at the TensorFlow serving documentation, where you can learn, where you can gain the more in depth knowledge. So as a first step, after building your model, you need to save your model. So you need to save your model in saved model format. This saved model is a universal serialization format for TensorFlow models. It is the most used, or it is the most used way to save the TensorFlow models basically. So you need to do that one as a first step, and the next step will be deploying your model. So at this point, we make a request to the server to get the result back, and this is the command for that one. So I'll be showing all these things in the demo, so you don't need to worry about that one. And yeah, let's see the demo. It's demo time. So what you will be learning here, what we'll be learning in this demo, okay, a bit of TensorFlow serving and its architecture, which you already learned a few minutes back. And we'll be building a demo project, finger count detection. Basically this is my old project, like Morse code detection. I used to detect how many fingers are open for that project. So I'll be using the same project, uh, where I'll be deploying the model somewhere, and then I'll hit that model to get the results back. And then we'll be saving the model in saved model format. And then finally we'll be deploying the model, and we'll be making predictions from that deployed model. And we'll be seeing two use cases here. Like what are those is, how to take the latest model when you have multiple models, or when you have a single model, how to take that one, or when you have multiple versions of the same model, how to take the latest one. And we'll be also seeing how to deploy multiple models to serve multiple tasks. So this is what we'll be looking in today's demo. So let's see how to do that one. Okay, so I'm a Windows user, so I'm using Windows here. So if you are using Windows, you need to install Docker, because for window if you are a Windows user, Docker is very important if you want to use the TensorFlow serving. If you are a Linux or Mac user, you don't need to install the Docker. You can directly uh, install the TensorFlow serving, and you can directly use it. But the additional step for the Windows user will be installing the Docker. So uh, why Docker actually? So there is a concept called containers. So why we got this concept? So usually developers will have an excuse like, okay, it is working on my system but it is not working on your system. So to solve this problem, we got a concept called containers. Let's say it is working perfectly on your system, then on your environment. So we will be creating a container around that environment where it is working perfectly, and then we can transfer that container to anywhere. We can transfer that onto the cloud, or we can transfer that to some other person, so where they can uh, take that container and run the models and do the operations directly there itself, so they don't face any errors, because you didn't face any errors, right? It is working perfectly on your system. So it will work perfectly on the other system as well, by using the concept called containers. So we'll be also using the same Docker concept here. So where we'll be taking uh, the working the working sample from the TensorFlow team. So they created an image, TensorFlow serving image. So we'll be directly using that one, and we'll be porting that image to our saved models, and then we can do some operations, whatever the operations we want. So before that, first I'll explain these two scripts. Yeah, one is to generate the model and save the model, and the other one is to do some Morse code. Like I'll be using the Morse code project, so it will be finding the Morse code from fingers. So first we'll understand the finger detection project. So here I just imported few libraries. On the dataset I'm using will be the fingers dataset, which I'm taken from the Kaggle. So if you want to understand how the data looks like, so this how the data looks like. So let's say 0 is a label where where the fingers are not open, all the fingers are closed. So this is the 0 label. So if you see, all those images will be the same. Here and there it will be tilted with some angle or mirrored, whatever. And the next folder is one. So one finger will be open in all those images, so we'll be labeling that as one. And in the same way, all the five, two fingers or three or four and five will be the same. So this is the test folder and this is the train folder. So this is how the data looks like. And then file structure should be in this format if you want to use the image data generator. So I'll be using the image data generator. So the format should be in this way. This is the main folder fingers, and inside that we need to have two folders. One is for train and the other one is for test. And inside that we need to have a separate folders for separate class, because we have five, let's say six classes. So we have six folders here: 0, 1, 2, 3, 4, and 5. And inside that folders we have the different images respect to that class. So this is how the format will be for the train and the test as well. And after you having this type of a format, and you can simply create the model. So yeah, this is how I explain how what is the data set is. And then next step will be uh, creating the model. So I'm using the image data generator. This is a function where I'll be passing the train path and the test path, and the batch size will be 128. And see, I'm not going in details of these scripts because this is not important for this tutorial. The only important thing is deploying the model. So I'll just give a high level overview. So this is an image data generator where you can simply, whenever you have that type of a format, image data generator works perfectly. So in that you'll be giving a few parameters like rescaling or rotation angle or width shift or height shift, zoom, and the same thing we'll be using for the training. But we don't do all these things because it is only for testing, right? So so we don't use anything here for the test. And then we'll be giving the path from where the images are. So this is the train generator, which is the object here, and we'll be giving the flow from directory, and where will be the training path where the training images are, and the target size will be 150 by 150. And then color mode is grayscale, and batch size and the number of and the classes labels we have 0, 1, 2, 3, 4, 5. And class model is categorical, and we'll be giving the same thing for test data generator as well. And after that, this is how the our model architecture is. So where I'm using the sequential, and we have some convolution layers and max pooling layers, and multiple convolution and multiple max pooling layers. And then we flatten the data, and then we pass that to the dense layer, which has around 512 neurons. And then we have a dropout layer here, and then again dense neurons with six neurons, because we have six labels, and that we have an activation of softmax classifier. So this is how the architecture is. And then we'll be compiling it. We have an optimizer Adam and loss as a categorical cross entropy, and we have a metric as accuracy. So we are not focusing on accuracy or the great performance of the model, so we don't need to care about all these things. We can just train some model. And then here we'll be training of the model, where we'll be just giving the number of epochs and number of steps per epoch and validation steps. So we use the image data generator, so we'll be using the fit generator here. So we'll be having a model.fit generator where we'll be giving the training data and the number of steps per epochs and number of epochs and validation data. So we'll be having the test data here and then validation steps. And finally, this is the most important, where you need to save your model, and it will be saved in the saved model format. You can just use simple command like model.save, and you will be giving some name for that one. So it will be uh, saving your model in a saved model format. And this is where I just given the a path and then image data generator. So finally it will be creating the model. So if you want to run this file, it will take some time. If you don't have a GPU, it will take more time. So what I did is like I just used Google Colab to train my model, and I saved the model there only, and then I downloaded and took that and given and took that and placed here this one. And this is how you'll be saving your model. And the next step, as I discussed, you need to install the Docker. which I already did that one. It is simple, like you can go to the Docker website and you can just download the application and install it. And as the last step, you will be giving the resources to it, like the RAM size or the disk size. You can just keep any numbers for that one. And yeah, and the next step is we'll be pulling the TensorFlow serving Docker image, because you can also create your own images, but for the simplicity, for explaining, for giving a good high level understanding for you, I'm using the same Docker image, uh, which is developed by the TensorFlow team. So I'll be downloading that one. So after the Docker is installed, run that one. And I'm using VS Code here. You can also use VS Code or any other editors, but this one is very good, so I'm using this one. So in the next step, you'll be in pulling that Docker image. So that Docker image is like uh, TensorFlow survey. So when you run this command, the tag will be latest, or you can give any tag. So if you don't give anything, it will take latest as a default tag, and it will download the latest TensorFlow serving image. And the next step, what we'll be doing is we'll be running that image in a container. We'll be creating a container, and in that container, this image we'll run this image. So once the download is complete, it will extract that image, and that part is done. So here, as a next step, we will be running our Docker. So we'll be running it Docker run and -d, and you can give some a name to that, any name. So I'm just giving some finger count. So this name will be your container name, and then you'll be giving the image, Docker image. Okay, once just run this command, so it will create the container. So if you are using VS Code, it is easy, like you can install this Docker plugin, and you can simply see there is a container here. So if you see the container, so if you see the name finger count, because I give him the name finger count, so the container name will be that one. So this part is done, and once this is done, you need to copy your models folder to the Docker. So you can simply do that one, like if you know the path where your saved model is, and you can just run that command. I mean, you can just give the Docker a copy, and this is the path where your saved model files are, and this is the path you'll be giving inside the Docker. So you'll be giving this path. So you'll be saying copy these files to this path. So let's say if we are done with this part, and then if you want to check uh, whether you copied it correctly or not, so you need to execute the Docker. So you'll be going inside the Docker execute and -it, and you can give the container name. And once you executed that command, you will be inside the Docker. So here you can just run the ls command. So you can see the models folder here. So just ls models. So you can see the my model folder here. And if you just do ls for that one as well, if you see the one here, so one is like version. So you need to define your saved models in a folder with some number, let's say the version number. So I'll just go inside that as well. If you just go inside that, you can see uh, all the files which are needed to do some predictions. So this is how the saved model will save all these files. Saved model dot pb protobuf file, protobuf format, and all the variables, all the checkpoints will be available inside the variables folder. So once you confirm whether that is copied correctly or not, so once that is done, so inside the TensorFlow, inside the Docker, so you need to run this command to uh, uh, to create a server. where you will deploy your models, and it will be creating a REST API for that one. So we can do it in two ways. One is gRPC, and the other way is the REST API. So we'll be using the REST API because it is easy to understand, it is easy to debug. So we'll be using the REST API. So we'll be creating that REST API right now. So we'll be running the command TensorFlow model server, and you need to give the port. You can give any number, but make sure uh, nothing is running on that port. So I'm just giving some number 8038, because the REST API will be running on port 8051 inside the Docker, and the gRPC, I think it is 8500, the port number is. So you can give any port number where that 8051 port will port to 8038 in your local host machine. So you can hit that REST API from outside the Docker as well, if you give a port number like this. uh, and then you need to give the a model base path where where your models are there. I mean, where you just copied your models, so you need to give that path here. So you can just give the model base path. So my models are saved here, model slash my models, right? And then you can simply hit the enter, or one thing where we can do is, like, we can give some name here. We can say some model name. You can give any name. So we'll be using the same name uh, while using the REST API. So you can just give the model name. So I'll be just giving my model. You can give any name if you want, and then just hit the enter. So your server is started and your model is deployed successfully. If you receive this message, your deployment is successful. If you didn't receive this message, there is something wrong with your Docker or with your uh, container or somewhere. So make sure you got this message. So if you see that it is running at a localhost 8038. So, and the next step, you need to test that one. So once the deployment is done, once the model server is up, you can use a command. You can simply check that one. uh, let's say you can use the curl, and you can just give the URL of that one. So let's say localhost 803938. What it is? Yeah, 38. So you can just give the 38, and you need to give the version 1, and then models, my model. This is the name which you just given while running that command. So you just hit enter. So once you run this command, so if you got this one, like this JSON format, where it will be showing the a model version status and version and state available, then your deployment is successful. So if you fail to get this one, there is something wrong which is going behind your deployment. So once that is done, so it's time for testing. So let's test our project, whether that is perfectly deployed or not. So this is the file where we will be testing our Morse code, like, with the fingers. So I'll just go through high level. So these are the parameters where you'll be giving for the box. There will be a rectangle box on the camera. So where you need to place your hand there itself, only there. So then only it can detect how many fingers are open, or the number of fingers open. And these are some parameters, threshold parameters or some kind of thing. And we'll be also having threshold in blur all, and we also have background threshold values, and the learning rate as well. And the other parameters like is background captured. The first thing is like we will be capturing the background, and then we'll be placing our hand over that background. So then the background will be removed, will be subtracted from that image. Only the hand image will be available. And we'll also have some mappings here, Morse code mappings. So A have 1 2, B is 2 1 1 1. So in Morse code we'll be having two things, right? One is dot and the one is dash. So here 1 means dot, 2 means dash. So for the simplicity, because we are using fingers, so I just given 1 and 2. So if you open one, it is, if you open one finger, it is dot. If you open two fingers, it is dash. So this is a complete mapping for all the characters and numbers. So here you'll be removing the background. So as I explained, like we will be removing the background, so only your hand will be visible. And then here you'll be capturing the video. So you'll start a video and you'll start capturing every frame. And we have a classes. We need to give the classes as well, like 0 1 2 3 4 5. And this is it will display the Morse code generator, this window. And once the window, the camera is open, we'll take every frame, and every frame will go through few filters, the smoothing filter, and the flip, we'll be flipping that as well. And it will be, and this will be capturing the rectangle box where you will be placing your hand. And this will show the original video. And once the background is captured, because that is 0 before, so to capture the background you need to press the B button. So once you press the B button, it will capture the background. So after capturing the background, and you can place your hand inside that box. So it will go through few filters, as I said. So first it will be converted to grayscale, and then Gaussian blur is applied on that, and then we also applied some threshold uh, to get the complete white image of your hand. And then we'll be resizing that to 150 by 150, because we used the same dimensions when you were training the model. And then we'll be converting that to array, and we'll be reshaping that one to send to the model in the format exactly what it is looking for. And this is the URL where you'll be hitting. So this is the host port, and this is this is your name which you just given while you're running that command. And you'll be giving as a predict here. So it will be predict, it is a predict function you are saying. And you need to pass the information in a JSON format, so where you'll be giving the signature name. You don't need to worry about that one. So we'll be giving the serving default as a signature name. There are multiple signature names, so you can give the same default one. And here you'll be passing the data. So you'll be passing the image data here. After doing some operations and getting in the right format, you can pass that to in a JSON format. And then you'll be giving some headers, and you'll be using the request, where you'll be doing a post request, and you'll be passing the URL, data, and headers. And then you'll be getting some JSON response. So where you'll be taking that JSON response into a JSON format, and then you'll be predicting the class here, what exactly that image is, like how many fingers are open. So it will be predicting that one, and it will put that text how many fingers are open on the screen itself. And this is the logic capturing the Morse code. So what is the logic is like, if you open three fingers, it says start capturing the pattern. And when you open the five fingers, it says stop capturing and predict the pattern, predict the Morse code from the captured pattern. And if you open the four fingers, it is space between words. And if you open one finger, it is dot. And if you open two fingers, it is dash in Morse code. So this is how this is the complete logic, how to capturing the Morse code. So it will be easy, you can just go through that one. And these are all the remaining things where you will be releasing all the windows once it is done. And if B is like capturing the background, and if you press the R button, it resets the background. So yeah, and that is done. We'll be passing some parameters here. So let's see how it works. So let me run the script. Let's say Python and Morse code .py file. So once you run the script, So it will open one window, uh, the camera window. So let's say I'll just capture everything. So this is the blue window, as you can see, where you need to place your hand here, and then once you press the B button, it captures the background and it will create the remaining windows where you can see how every filter is going on and how it captures. So let me place my hand. So this is 0 or something. Sorry. Okay, let's say. Uh, Sorry, let's reset the background so it will be clear view. So I'm just resetting the background and let's capture the background again. So I'll just place my hand here. So once okay, so if you see, there are four windows here. One is which will predict, and the other one is after removing the background. And these are the other two filters, the blur filter, and this is one the threshold, which we just give some threshold. So let's predict some Morse code. So let's say, let me print hello. So for the H, there is some pattern. So I'll be doing that one. So I'll open three fingers, which says start capturing the Morse code pattern. So I'll close it. So it will run. So if you can see here what it is predicting. So I open four dots, and if I open five fingers, it will predict that character. It will stop capturing the Morse code and it will predict the pattern. So once I close and open the three fingers, and it starts capturing for the next character. Open. So we got HE. Somewhere it predicted 4, so we got some space here. So we again 3 opens, and let's see 1, 2, and 1, 1. So you can see HEL, and let's say we open 3 again, and let's start 1, 2, 1, 5. So we got hello if you see. So this is how this is a small project, not an optimized one, uh, which is a naive project. So if you want, you can improve this project. If you want, you can work, or we can work to improve the performance of this project. And this is how exactly it works. I think I hope you enjoyed this project. I hope you will enjoy this project, working on this project. So so we understood how to deploy the model and how it works. But what if you want to give a new model, like you improve the performance of this Morse code project, and you want to deploy this one. You want to you don't want to use the previous version. So what you can do is, so as I shown you here, inside the Docker, if you just see this folder, you have a one here. So right, this is a version one. So what you can do is you can create another folder with the name of then with the next number 2, and you can just go the saved model inside that 2 folder. And basically this TensorFlow will be taking the latest version by default, which has the highest number. Let's say you have a version 3 which is highest than 1, so it will take the third version. If you have a 4, it will take the fourth version. So it's as easy as possible, like you can just give the folder name as the version name, and it will take the highest number as the latest version. So this is how you can do that simply. And the other use case, where as I said, we'll be looking at multiple use cases. So that is one use case where you can just auto updating the model with the new version, where you can just simply give the next number, the next folder name with the highest number. So that is one way. And the next use case is deploying multiple models. So if you want to deploy multiple models for multiple use cases, so you can simply do that by creating a config file here. This is a config file where you can just create a model config list. You can just give multiple model names here. So you can just copy this one and give the next name, next config, let's say model 1, and we'll be giving the base path for that one. So let's say my base path is this one, and This is how simple you can just define multiple models. And if you want, you can also define the version which to use for that a specific model. So that is also easy. You can just simply give the version policy and specify the version name. So you can simply give the version name here, 1 2 or something, or you can also do the same thing for this one. You can just give the version names here. If you don't want to give the version names or take it by default, you can just simply give in this way. So it will take the latest version, the highest number in that version policy. And this is as simple as possible. And if you want to run these multiple models at the same time, you need to copy this file. So I think I don't have that one, so let me run that. So here we have a copyright, so you can just simply copy that file. Let me copy that file, models.config, to this folder inside the docker. Let name the same models.config. Okay, there is some error. Let's say it's not the name, finger detection. So I just given some wrong folder name. So once this is done, uh, you can simply, so once you stop the once you run this command, so you need to remove the docker file every time, or else you can simply create a docker final image, and you can simply do that one. uh, I'll also give some steps how to do that one. So once you copy that model config file, so here you can just specify, let's go to inside docker. So once you are inside the docker, so you can run this command. So before we given model base path, right? So this time we don't need to give the model base path. We can just directly give the config file, because everything is specified in that one. A base path, if you see here, there is a base path and name as well, so we don't need to define the base path and the name. um, so here we can just only we just need to give only the config file path. So once that is done, config file, so just give the config file. So if you see, we got the models.config file here, and then you can just simply run this command, where you'll be just giving model config file instead of all those uh, base paths and the names. So because we already mentioned all those things in the config file, so we can simply run that command, and we are and the model deployed successfully again. So this is one use case where you can just give the where you have a multiple models to deploy and each model to serve some separate use case. You can simply do that one. Or let's say A/B testing, you have multiple models, and you can just give the different names for the same model, and you can just give that access to all the users, where you can do the a perfect A/B testing. So this is one case. And if you want to, let's say, you got a new version of the model, okay, and whenever you got a new version, what you will be doing is you will be simply stopping the server, and you will be uploading the new things, right? Where you'll be simply stopping and giving the new version files. So one thing what you can do easily is you can specify the version here. Let's say you just changed it to the 2, or you can just change it to the 3. You don't need to stop your server. You can mention your you can say to your server that refresh the, I mean, get the config file after after particular time every day. Let's say get the config file every day at 9 p.m. So what your server will be doing is, like, it will be getting the config file every day at 9 p.m. So whenever you change the versions, it will take the latest version based on the configuration file. It is as simple as this. So you can just simply specify the version names here, instead of stopping the complete server. And uh, you don't need to stop your server again and again. You can just simply specify the version here, and you can give the command for that one, as where you'll be giving the config file here. And you can just simply uh, give this parameter, model config file, poll wait seconds. So if you say wait for 30 seconds, it will wait for 30 seconds and get the configuration file. So whenever you specify new version, it will get the it will load the new model. So you don't need to stop your server again and again. And the other use case is like when you want to roll back to your previous stable version. So it is very simple. Like, you can just change the version name and done. Your model server will again get the new configuration file, and it will load the roll back the model. It will load the previous version. So it is simple. So these are the main use cases. I mean, there are a lot of optimizations for TensorFlow server, which I'm not going through in this video. I'll be doing that in the later videos, where we'll be applying more optimizations to completely optimize your server, where it can use less computation and give a more great performance. So I will explain them in the next videos. And this is done for this video, like, where we'll be just only deploying your um, deep learning or machine learning models using TensorFlow serving. Uh, I hope you learned something from this video. I know you'll be getting a lot of errors if you are a beginner, where you're dealing with the Docker and the stuff related to the Docker. If you faced any issues, please ping me separately. I mean, please, you can ping me through mail, or you can ping me on Instagram, where I'm available. So I can solve all your problems, whatever you faced regarding TensorFlow serving. And one last thing is, like, and happy Diwali to everyone. Keep the air clear, and for the safe and clean festival of lights. Let's avoid firecrackers this time, and we can celebrate that in the next year. We can celebrate it grand in the next year. So share love and lights this Diwali. And thank you so much for watching this video. We'll meet you in the next video with the other demo soon. Thank you so much. Bye.